Okay, good morning. Welcome to
FamilyMath number 1139.
FamilyMath 1139. Sorry, get a little piece of hair there. Today we're going to take a look at one of my all-time favorite math problems. And it's a problem I learned from Larry Guth, who's a math professor at MIT. And it is called the no rectangles problem. And we're going to start with the 3x3 case and then see where we go. So the question is, what is the largest number of squares that you can fill in on this tic-tac-toe board? And I'm saying filling them in by putting one of our stamp cubes there without forming a rectangle. And a rectangle is going to be defined as four separate squares whose corners, who form the corners of a rectangle. So for example, that is not a rectangle. Why not?
Well, you only have 3 squares.
Yeah, so even though you would say, hey, wait a minute, that's a rectangle, that's not what we mean by rectangles. I mean 4 separate squares who form a rectangle. So can you give me an example of a different rectangle?
Well, this one. This would be
Okay.
the smallest one you could make.
All right, and can you give me something that has 4 but does not have a rectangle?
So I think this would not be a rectangle.
That is correct. And actually,
Because even though it's kind of like a diagonal square, it doesn't
No.
count.
you're right. That's a great example, actually, because even though that is technically a rectangle, I guess I need the definition to be a little bit more precise. They form a rectangle horizontally and vertically.
Mm-hmm.
Yeah, so thank you for that example. That was a good save. That is not a rectangle in our game.
All right.
Okay, so for the 3x3 case, what do you think is the most? Or sorry, you don't have to know the answer immediately. But what are some ideas you have?
Well, I see a way to get 5 at least. So if you fill in this top row with rectangles and then the middle row, now you can't put any more than 1 on each of the 2 rows.
Okay.
So you do that and then you get 5.
All right. Okay. So we've got a way to get 5. That is good.
All right. I'm not sure if we can do better, but how I'm thinking about it is that we can't have all the corners filled.
Okay.
So maybe we fill 3 of the corners.
Interesting.
And then from here, we can just kind of try to put stuff in. So we can put this middle one in. That doesn't do any harm. And now we have these little squares here. So we can't fill both of these. We can't fill all 4 of these. We can't fill this one. It looks like we can fill this one.
Okay.
But then I think
Well,
anywhere else you can't fill. Can we
this
fill
one you
here?
can fill there.
Yeah, we can fill there.
Yeah, so it looks like you can get 6.
I'm just sorry. I should have checked this at the beginning. Okay, good. That's on camera.
I guess that makes sense. So it's symmetrical. And then we can't fill here because it makes a rectangle with these 4. Here makes a rectangle here and here. This makes this rectangle here
All right.
and this rectangle.
Okay, so we got 6. That's interesting. Can we get 7?
Well, to get 7, you would have to completely fill one of the rows, or at least one of the rows, and then the other 2 rows would have to both have 2, or one have 3 and one have 1. Say that if you filled the bottom row, then you would automatically form rectangles with both of the rows.
Okay. Why? I want to ask you about your first statement. If you have 7, why does one row one row have to have 3, or at least one
Well,
row?
you only have 9 slots. You have to pick 2 open slots, and there are 3 rows.
Okay. Good reasoning.
I guess the other case would be if you put the 2 open spots in the same row, but then you would form a bunch of rectangles with these 2 fill-in rows.
Okay.
It doesn't look like you can get 7.
Okay. So what have we shown here?
6 is the max.
And how have we proven that? Actually, we actually have proven that 6 is
So
And we showed we can get 6, and we showed we can't get more than
Okay.
6.
Good. All right. That's really nice. There's another kind of neat one with 6 that I wanted to show you.
Yeah.
What's that? Do you think that's the same or different than the one you had?
I mean, it's the same idea, I think. We don't have the center filled and we don't have two of the corners filled.
I think as long as you have maybe 2 squares filled in each row and 2 squares filled in each column, you should be good.
Yeah, actually, I think ours was this way. So, yeah, you basically can only have a max of 2 per row, and I guess there's 2 different ways to do it.
Yeah, or maybe more than 2 even, but this was your way, I think, and essentially the way I showed just flips these 2 rows.
Yeah.
So if there's no rectangles before you flip them, there's no rectangles after you flip them.
Yes.
All right, very good. Let's move on to the 4x4 case.